Hello, everyone, and welcome to today's webinar. I just want to mention it's really great to see so many participants here from all over the world on with us today. So I do want to thank everyone for sharing your time today. I'm Joanne Emery. I'm the Event Director at Infonetics Research, and today's session is going to focus on key performance indicators for mobile operators. And the title of the webinar, as you can see, is Optimizing LTE and LTE-Advanced Networks with the Right KPIs. And our webinar today is co-presented by Infonetics Research and our partners Accedian Networks and JDSU. So now I'm just going to do some quick introductions of the panel and we'll get started with the presentation. First, leading our discussion today, we've got Stefan Terrell. Stefan is Principal Analyst at Infonetics Research, and he leads the mobile infrastructure and carrier economics coverage areas. Stefan, hello, welcome.
Hello everyone. Thank you very much, Johan.
Very good. And from Accedian Networks, we have Scott Sumner. Scott is the Vice President for Solutions Marketing at Accedian. Scott, welcome.
Thanks. Thank you, Joanne. Very nice to be here.
Great. And rounding out our panel, we have Paul Gowans. Paul is the Global Mobile Marketing Manager at JDSU. Paul, welcome today.
Thanks. Hello, everyone.
Great. And now I'm going to turn the controls over to Stefan, and we can get started. So, Stefan?
Yeah, thank you, Joanne. So, in saying hello means good morning, good afternoon, good evening, and good night, because when we look at the audience, there are people from everywhere in the world, and we really appreciate that. So the title of the webinar, Optimizing LTE and LTE-Advanced Networks with the Right Key Parameter Indicators, is in fact something I come across everywhere on this planet. Everywhere I visit a mobile operator, they talk about their issues, and most of the time the KPIs are actually on target, but it doesn't mean that the user feels the same way, and that is a big challenge. And if we look at market trends, which is the very first section of this webinar, the challenge is not disappearing anytime soon, because in fact we are more or less at mobile penetration right now. I mean, there are as many human being subscriptions as human beings living on this planet. Now, I agree, you really have to look at how you count that, and the GSMA actually did some work, interesting work, showing that there are many double counting, because you have people mainly in developed nations who have 2 or 3 phones. And so that is the little discrepancy when we look at global mobile penetration. However, it does not remove the fact that we have 7 billion, more or less, mobile subscription to handle, and that is very challenging for every mobile operator. So the interesting part of this chart is that the mobile subscribers are still coming from China. India is still a contributor, although once in a while it declines, and this is due to low ARPU, and it's just a one-time, 1 month type of subscription, and then it disappears. And that also depends on how the government is counting those subscriptions. Brazil, and you can see, I mean, we used to talk about BRIC. Russia has long disappeared because Russia was saturated 10 years ago already. So Russia is not contributing that much. Brazil is saturated and is still contributing a bunch, but China is just amazing. The other interesting fact is a lot of people are still on 2G, actually roughly 2/3, the rest on 3G. That means we have a huge, long migration ahead of us, and that is 2G on 3G, or maybe leapfrogging and moving from 2G to 4G, but we all have 3G to 4G as well. And when we look at 4G, through 4G is actually LTE-Advanced, according to the IMT 2000 sets of technologies. And we are moving there, in fact. And that is the new challenge, adding on top of every mobile operator on this planet. We have peaked last year In fact, if you really count the total number of LTE networks deployed in 1 year, 2013 was the peak with 116 or 18 networks launched in 2013. Last year we had 96 networks launched, and that means we have a cumulative total of 360 LTE commercial networks in the world, on the planet. That means we have passed the total number of upgradable networks, mobile networks on the planet. There are pretty much 580 something mobile networks on the planet. And let me clarify something. If you take the case of Telefonica, they have more than 40 single networks in Latin America. So I am not counting mobile operators. I am counting, and in fact, not me, but the GSA, the Global Mobile Supplier Association, is counting the number of networks. If you stay in Europe and you look at Orange, they have networks pretty much everywhere in Europe and in Africa. So that is part of the total. This is LTE, ladies and gentlemen, 360 networks. But hey, guess what? LTE-Advanced is advancing and enabling mobile broadband. Now we have 49 LTE-Advanced networks deployed in 2014, and talking to service providers, it looks like 1/3 of the total LTE networks are poised. I mean, those existing 360 networks are ready for an upgrade. So that's good news, but in the meantime, you have to take into account several things. We talked about billions of connections, and I showed those billions of connections for human beings only. I did not talk about things, Internet of Things, and that is way above my 7 billion mobile human subscription. In fact, you can multiply at least by 7, by 2020, and according to estimates from Ericsson, for example, and then you end up with, almost 50 billion connections. So the question is, whoa, wait a minute, how do you handle that? This is a very different animal, right? The machines are not behaving the way humans behave. And that means you have different traffic profiles as well that you need to take into account. Whoa, this is no longer, typical voice call. And speaking of voice, 2G voice is moving to LTE, VoLTE, and that is also adding to the problems of handling a VoLTE call. You still have 3G there, although some mobile operators are phasing out 2G. I mean, AT&T in the US, but you can go to Thailand, they are actually phasing out 2G. Brazil is phasing out 2G and moving everything to 3G, eliminating one big block. However, in the rest of the world, you're going to have to deal with all these things. And back in the day, in the late 90s, when I was working on those GSM base stations, we only had 4 KPIs. Then we moved to 3G, slowly actually, in the early 2000s, and Telecom was the very first one, 2001, 40 KPIs. Not a big deal, but now, hey, these 400. So if you look at the small typical networks in Europe footprint, you end up with 3,600 KPIs. How do you handle all that stuff? And that's not over, because we are adding small cells for better coverage and capacity. So we have also an ongoing onslaught of applications and services. As a result of that, we are totally inundated by big data. And that big data, if used properly, can really help. So this is the intent of this webinar, to look at a cut of that big data and see what we can do to really have a network that performs very well in LTE and LTE-Advanced. So now, ladies and gentlemen, what I would like to do is to ask a question and have a poll and see what you think. So the question is, what part of the network most demands KPIs to ensure proper delivery of mobile services? Is this the radio access network? Is this the edge of the network, the core, or everything? All of the above. So let's see. Well, as you can see, 61.5% of the respondents say, you know what, it's all of the above. We are no longer, and I'm saying no longer because I remember 15 years ago exactly when we started this 2000 with 3G, everything was still in the RAN. We were still trying to optimize the RAN, and it took a long time actually. Until 2007, we were still trying to adjust the azimuth and looking at KPIs and everything. But wow, I mean, this is a major shift, ladies and gentlemen. Today, with LTE and LTE-Advanced, we are saying we have to make sure the EU TRAN, as a matter of fact, edge and core are, performing very well. So we need key KPIs in all areas of the network to make it happen. So with that said, let's move to the very first section, looking at problems and challenges. And for that, I would like to invite Paul to start.
Okay, thanks, Stefan. So I think Stefan's given us some good market data on kind of where things are. Before we get into some of the kind of specifics around kind of KPI and KPI generation, I just want to touch on some of the operator challenges and also some of the network evolutions that underpin the whole area of KPIs and end-to-end management. So I've highlighted here really kind of 5 top operator challenges, from differentiating customer QoE, and of course that's a key one right at the top of pretty well every operator's agenda, but also importantly kind of aligning that with the greatest business impact, and that business impact I think is an important part. The second one about scalability, this is really about trying to move away from the relationship of the linear relationship of network costs going up as data volumes going up. Things obviously have to kind of change in that environment as kind of volumes are doubling every year. So how do you kind of optimize that total cost of ownership and scale up to the volumes that you require? And of course that has major implications on end-to-end management and KPIs. The third one is about time to revenue, and this is about getting things out there quickly, but importantly generating business and without compromising quality. I guess kind of anyone can kind of get something out to market. The question is it going to generate some value to the bottom line, and is it going to do that with a high quality service? Everyone's talking about the evolution to virtualization. Lots of business benefits, of course, around that, but at the same time, there's a significant amount of risk underpinning that, and that's a key area. And then the last one, I'm probably the most important one, which is operators being able to grow and diversify revenues. It's not about costs. It's not necessarily just about efficiency. It's about how do you kind of grow your business and grow those service revenues. So that really kind of highlights what we would bring forward as the kind of 5 operator challenges. Now, at the same time, the networks are evolving. So I've split this up into really kind of 2 dynamics, and they're both going along in parallel just to add that extra level of complexity. So on one side, you've got cell site evolution going on, whether that's small cells or DAS or HetNets or Cloud RAN, or I don't know, liquid RAN or whatever you want to call that. You've got a whole bunch of changes in terms of kind of fiber and fiber to the antenna, remote radio heads, CPRI. You've got the demarcation necessarily between front haul and backhaul starting to kind of disappear, where that would have been a kind of clean break before. So that's all going on at the cell site. Then at the same time, LTE, of course, is not standing still. The standards and evolution of that continue abound. We're talking about LTE-Advanced, there's LTE unlicensed, there's voice over LTE, there's MIMO, there's EMBMS in terms of LTE broadcast, there's self-optimizing and self-organizing networks, And then, of course, this whole area about, NFV and SDN, software-defined networks. Significant amount of kind of complexity as we continue to kind of evolve the network infrastructure. And just to kind of show, how kind of cell sites are moving, we're going from what is typically a kind of conventional cell site with kind of copper front haul, very kind of traditional, to much more of a distributed cell site environment, fiber much more endemic here, distributed antenna systems, small cell environments, with kind of active antennas. And of course, as things evolve, typically what happens is that an operator has all these types of cell sites all going on at the same time, and of course while LTE is evolving. And just talking about the kind of LTE evolution, we touched on kind of LTE-Advanced there. One of the key aspects, of course, LTE-Advanced is around carrier aggregation, and this allows operators to aggregate component carriers, potentially 5 times 20 megahertz up to 100 megahertz, because typically you've got spectrum in different parts of the whole bandwidth domain, and being able to kind of pull those together. Maybe it's 800 megahertz and you want to kind of combine that with 2.6 gigahertz, pulling those together and being able to aggregate those into bigger pipes. And that's part of the, as we mentioned, the kind of LTE evolution. And often this is combined with MIMO, multiple antennas. So as you can see, there's a lot of evolution going on that affect those kind of key challenges, and that feeds into really how you go about kind of KPI and KPI generation. So let me just pass over to Scott, who's going to talk a bit about performance metrics.
Well, thank you, Paul. That's certainly shows the spectrum of how all of the technologies are changing. I just want to build on that and really show how the number of KPIs out there and the amount of data really creates the mountain of big analytics in one way. If you look back a few years before all of these changes started happening, you really had these macro towers and the end user out there, and things were fairly simple. What we're seeing now is a trend towards densification in sites, as well as in the number of end users, of course, as Stefan mentioned, but also in the number of traffic flows per site, as each backhaul connection needs to support multiple carriers, like legacy 2 and 3G with the LTE or LTE-Advanced, and different types of traffic going over each that need to be managed separately. So these involve different KPIs and also collect a lot more KPIs from the network. So there's a big trend to measuring everything from everywhere to try to get some control over these networks that are kind of exploding. But when you look at each device and how it's able to report metrics, sometimes you find that the devices themselves are under high load conditions, and the CPUs that generate the metrics are not doing so in a very accurate way. So the most important metrics to an operator, the most important KPIs, come out of the network when it's under the highest load so that problems can be solved. In this case, you may have some issues in the accuracy of what you're seeing to be able to make decisions and act upon those. So I think the most important message from the large amount of data coming in is that quality may be much more important than the quantity in terms of how we can look at the KPIs in the network. So some other challenges that exist there in terms of actually conducting measurements. You have a very asymmetrical network in mobile networks, and that's even more so at different times of day or different locations or different technologies. So we have to be able to see these network links in a directional sense to be able to measure KPIs that can tell you, for example, if a VoLTE call is working for one caller but unclear to one at the other end of the call. In addition to that, of course, these LTE-Advanced scenarios and deployment have performance requirements on the backhaul, on the radio network itself in terms of synchronization and timing. And the allowable delay in these networks is diminishing rapidly, and the amount of synchronization required is now approaching to the multiple hundreds of nanosecond domains. So we have to be extremely vigilant in this to make sure things keep working properly. And then you have a lot of TCP traffic that's in the network. And we talked about Internet of Things just a little earlier. And there happen to be very chatty devices that create a lot of TCP streams that can create microbursts. So that can impair the throughput in the entire network in the way that the TCP protocol works. So sampling rapidly and having real-time visibility here is critical. And I guess finally, one of the main points of visibility we need in the LTE evolution is this new X2 interface prevents us from doing a lot of centralized core testing. We really need to be able to see between sites as well, so some legacy solutions won't allow this. We need to see a full mesh of performance across the network to be able to see things properly. Some other interesting aspects of the evolution of LTE in the network is really not only that we have to look everywhere across the network and instrument things uniformly, we have to be able to provide these metrics to analytic platforms that are going to be able to digest this massive amount of data, or even controllers. And we have to look at interoperability between different elements to make sure that we are able to monitor all the different layers that are relevant to performance management, as well as being able to roll up these metrics into meaningful KPIs that we can then use to make the KPIs that are actually important, or combine KPIs together to make a meta KPI that would actually indicate something, sort of the needle in the haystack, so we can get some visibility. So I'll pass this back to Paul to introduce, or Stefan, sorry, to introduce our next chapter.
Thank you, Scott. So, yeah, as we saw, there are many problems and challenges, and in fact, there is no shortage of that. And, to me, the key challenge from what I've seen here is how do you generate business without compromising the quality? Because the quality means the user will stick around. With that said, let's look at new options and solutions to solve these issues. So I'm passing over to Paul.
Okay, thanks, Stefan. Yeah, it was good to see the result of our poll earlier on about all the above, because I think that really is a fundamental point about managing anything. It has to be done kind of end to end, because your service delivery is end to end. It's from silicon to service, if you like. And it's a chain end to end. So if there's any breakage in that chain, it's going to affect the overall end to end service. So I've highlighted, for example, been able to look at, from the RF side, from the handset, right the way through the RAN and edge, right the way through to the core. Real-time insight is very important as well here, because you've got some services that are operating in real time. Maybe it's video, maybe it's VoLTE. And then knowing things real time and being able to react to things is a key part of any kind of KPI infrastructure. I think the other important thing is here is moving away from just kind of network related KPIs and knowing things at the kind of service end to end. The measurements that you get need to be app aware. They need to be kind of service aware. And to be able to do that, you need to look at basically combining both the user plane, so that's the kind of whole service delivery, and also the control plane, which is all the signaling, etc., that goes on. If you're off a particular maturity, you'll remember, for example, SS7, where, for example, the control plane's separate. We're moving to that, for example, with things like kind of IMS, which provides an infrastructure, for example, for IP-based multimedia services, like, for example, VoLTE. And, of course, the whole SDN, software-defined networks, evolution is all about separating user plane and control plane. So pulling that together and knowing what's happening both at the signaling level and the user level is fundamental. So, knowing things against RAN, backhaul, and core really is key. So on that, let me just hand over to Scott, who's going to talk about network state metrics.
Thanks, Paul. Yeah, there's definitely this need to be able to see at every layer and see what's happening at the user experience level. And I just want to show a little bit of the span of the base level metrics that will be underneath there to provide the correlation at the measurement plane of the network itself, and how these can be viewed. So even if you have metrics that are running into the higher layers, this shows an example of how metrics can be very useful if they're actually presented in multiple ways. So we take some very basic metrics here that even many operators don't have available to them network-wide in all the locations in their network. And if we can multiply those by the statistical variance that allow us to sort of isolate things very quickly over a sampling period, you can see that these things multiply very quickly. And a lot of operators I talk to want to look at things in terms of percentiles. They don't look at just every single alarm that goes off, but if alarm goes off after 95% of the traffic through the network is having a delay above a certain amount. These metrics are only useful if you can slice them into, as Paul was saying, into flows or metrics or ways that you can actually segregate this into parts of your network or the customer itself or a session that needs to be analyzed and optimized. So these are different ways of slicing these metrics or collecting them actually to begin with to make sure that they follow the operator's plans for collecting the proper KPIs for their own analysis. And then further to that, there's these complementary metrics that are based on stats from the packets themselves and or on-demand testing. And the idea here is to be able to correlate these in a meaningful way so you can isolate problems and determine the root cause very quickly. And for each operator, these metrics may be different in their level of importance, but having these available uniformly across the network is extremely critical. Just to take a look at the concept of a real-time feed of this, is to make things actionable, to make sure you have alarms that can tell you what's happening in a per second as opposed to waiting several minutes for some updates from the network. A lot of the probing systems are out there now will be able to pre-process metrics as they arrive into the probes and then analyze the different variants that are statistically necessary to have a proper view or the right KPIs, but do that in real time so that you can choose which KPI you do wish to action on in each direction, and then feed those into a system that may be related to your fault management or network optimization. So these are the kind of concerns I think operators are facing, is they want to get control network-wide, but they also want to be able to see this in real time, including the KPIs that are critical to them. They don't want to query a database and wait 15 minutes for a result. Back to you, Stéphane.
Yeah, thank you, Scott. This is amazing, actually, to be able to visualize everything in the network like this and have a tool with some automation that can correct the course of where the network is going. Fantastic. So let's move to service provider deployment applications, and starting with Paul again.
Yeah, thanks very much. Yeah, so one of the key messages is really, in terms of kind of KPI generation and delivery, is about moving from what I would call transactional to procedural KPIs. So originally, we would have built, for example, KPIs around kind of raw metrics, and this could be relating to, transactional level, handset connecting to the network, handset downloading service, and there can be hundreds of messages just turning on a phone, and we realized that we have to kind of get away from that and move to things that are more around a kind of procedure and policy. So the way I've represented this is having those raw metrics, normalizing them, by abstracting the relevant data, and then combining those into the kind of KPI you want, and then pulling that together at a policy, and then really at a kind of service level. So then you're kind of building your KPIs around business impact of services. And you can even combine that, for example, against contracts you have, for example, with kind of large enterprises. But the important thing is being able to kind of abstract that data. Maybe it's around VoLTE, maybe it's around video. Have a kind of hierarchical composite view to build these what I would call what are really key PIs, not just lots of PIs. And an example of this as well is that the what I would call kind of SMARTMetrics, which is really not treating all traffic the same. So again, we would have, for example, built KPIs and measurements all the same for every service and for every subscriber. Now we have to kind of look to more kind of value-based monitoring. And again, this now allows us to do that decoupling of the total costs of ownership of a system to deliver those KPIs against the traffic growth. So now you start adding some smarts in here. So if it's, for example, low volume events, you might build records for those. But high volume events, maybe it's an HLR connection, maybe it's an IMS connectivity, you might just want to count those. If there's been a successful procedure going on, again, you might want to just count that. If there's been a fault or an issue, you might want to build some more detail into that. And again, at the kind of service level, if you've got some activities like some BitTorrent stuff going on, maybe some YouTube stuff going on, these kind of free services, they might be chewing up a lot of bandwidth, but you don't necessarily want to have detailed call records on those. You just want to kind of build some high-level kind of abstracted measurements. Whereas on things like, for example, like VoLTE, or say you've got some VIP customers, you might want to build some detailed data and analysis on that, and ready to look at, for example, some quality experience. Maybe it's a MOS score, maybe it's a PES score. So I think this kind of decoupling, not treating all traffic the same, and being able to do that in real time is a key aspect. And just on that real-time component, I'll pass over to Scott, who's going to talk about real-time visualization. Thanks, Scott.
Thank you, Paul. Yes, I mean, if once you've got down to the point where you have an issue, let's say in a VoLTE network, and you want to look in detail and try to isolate the problem, one is important to have real-time visibility, of course, so you can see on a per-second basis, for example, what's happening. So if you make adjustments to your network, you can immediately see if you've made a difference. But also correlation, so having the ability to see multiple metrics overlaid on top of each other and see if one necessarily trends with another. And a good example of this would be microwave link, where you might have variable capacity on a link. It's a very hard thing to measure in real time with these links fading and potentially interference and other things happening, especially in a self-organizing network. But there are combinations of metrics that can give you a very good idea of what's going on. So if, for example, you see that the utilization on a link is dropping, and you also see that the packet loss is increasing, those two together can indicate very clearly that there's a capacity issue. So having this available in real time means you can go into things like your radio and make some adjustments and then see if those problems are regulated. That's one aspect of it. I want to show a service provider application that we recently addressed where they had a very difficult network to instrument, and unfortunately this is not an unusual situation. This is an operator who is a national operator in Europe who has a lot of different networks stitched together through acquisitions and through their own topology differences. So in the core of the network, really, they had 8 different IP MPLS domains in there. They had attached to those MPLS TP, so layer 2 domains, actually connected to all those through fiber and microwave to different backhaul sites. So overall here, about 3,000 different links were of concern to them to instrument, and it was really a problem that we can collect certain metrics from certain parts of each part of the network, but really bringing them all together and getting a unified view over these various technologies, topologies, domains, media was extremely challenging. And this is something that is the role of an instrumentation layer in a network. It's the role of some sort of unification and performance assurance system that can go out there and stitch together the results of end-to-end, but also provide segmented metrics that can be rolled up into uniform KPIs that indicate how the service is doing, regardless of the vendors in the network or how these things are put together. So one thing to basically take away from this is that this operator found the most important part of the whole KPI scenario is to have uniform visibility of this over the entire network, as opposed to having fantastic KPIs for just a subsegment of the network and then discontinuous KPIs elsewhere in the network. I'll pass this back to Paul.
Yeah, thanks very much. Yeah, so looking at this kind of end-to-end model, if you like, I'm just going to kind of go out and in. So if I start off at the radio access network, one of the kind of key things here is about getting geolocation data. For example, say you want to deploy some small cells. Knowing precisely where you need to position those is fundamental to delivering a personalized experience. So where to locate them, to optimize your performance. Now, one of the best ways of being able to do that is to capture network-wide visibility 24/7 from your network edge and geolocate that data. That helps you enormously to identify hotspots and being able to do that from real customer traffic and do that down to kind of building level resolution. You can then kind of profile hotspots by traffic type, by device type, by user groupings, and then make those business decisions on what's happening across my network from the RAN perspective. Where do I put cells? Do performance engineering? Even pass that data on to some of the engineers who then need to go to look at, for example, like some interference issues. Very fundamental here, because what you typically find is, and we found this from some of the analysis we've done, 50% of the traffic can be generated just by the top 1% extreme users. So knowing where those users are and how you deliver the network to those kind of performance users can have a major impact on the performance of your overall network. And then the other thing to think about is, how do I use data as well from the user device? Devices can act in different ways depending on what type of device they are, maybe what operating system they're running, etc. So being able to do, for example, device testing and combine that data with service testing, and being able to do that, for example, doing a walk test. So here, for example, I'm showing an example of doing a walk test around a stadium where you're able to combine RAN type KPIs. Maybe you're getting some signal receive power or signal to interference noise ratio. You pull in those RAN metrics, but at the same time you're doing some active service testing. So you might be, for example, doing a VoLTE or downloading a video and combining that with the RAN metrics and doing that as you do a walk. So different parts of, for example, the building or the stadium or the mall you're in, you're able to kind of get that information in real time and react to it in real time. So that's often a kind of fundamental use model that many of our customers use. And then if I go kind of further into the network, into the backhaul, monitoring and managing the backhaul, is becoming increasingly complex. As we talked about, those architects are changing. Often you've got hub and spoke type architectures, which can often have blind spots in the network. Again, it can be quite costly to be able to kind of instrument that network. But if you can embed some of that instrumentation into the network elements themselves, it can have a major impact on the overall total cost of ownership of capturing the information, and then you can use that data into your systems for activating, for monitoring, for delivering kind of end-to-end service. You can get kind of very granular kind of per service information down to that level. So that's some ways of basically doing kind of KPI generation, capture, and usage from the RAN right the way through to the backhaul. And we'll talk about the core in a few minutes. But in the meantime, I'll hand back to Stefan.
Well, yeah, thank you. And thank you, Paul. As I said, there is no shortage of challenges and issues, but what we can see is that this is the same thing, actually, when it comes to options and solutions. And, in that tsunami of potential options and solutions, it may be actually difficult to pick up the right approach. I don't know. But anyway, I would like to remind the audience that you can ask questions and you can submit your questions. We'll have a full Q&A session after the conclusion. So please be active and don't be shy and ask your questions. And now we are moving to the sponsor approaches with Scott to start.
Thank you, Stefan. And I think, as opposed to just looking at a sponsor-based approach, I think what I want to show here is a little bit in the line, I guess, of what Paul is also referring to, is that we want to use network-embedded capabilities as much as possible. We have a lot of different endpoints in the network, and we want to be able to instrument this completely, and that takes a variety of different form factors of technologies. So probing technologies, which we show here as actuators, performance elements and network interface devices at certain demarcation points, smart SFPs and small modules that can be virtualized and enhance a lot of different locations at a very low cost point without losing any of the functionality of a main test set. And then you have the software agents that Paul's referring to, as well as the standards-based reflectors that need to be embedded directly when possible into network elements. And many do support this already, which means you don't have to deploy instrumentation just to get visibility. And when you combine these things together in the right way, you can certainly provide a uniform instrumentation layer over the network. You can control this, all the third-party elements, what's already infrastructured there, and really get a full performance monitoring view, as well as service activation testing from a platform that can unify this information and pass it on to other systems that are able to digest, automate, and control these metrics so they can become dynamic. If we want to focus all the resources on a certain area of a network that has a problem situation and you want to see a higher resolution of what's happening there, because that's the best way to troubleshoot, then these systems have to be programmable. They have to be open to other platforms, and they have to be interoperable to everything that's in the network, both northbound and southbound. And I'll let Paul explain as well.
Yeah, thanks, Scott. Yeah, so I just want to show a kind of top-down KPI analysis approach. So starting from the top, you've got a kind of location view, I would call that, which is, again, could be using your core data with some geolocated data, could be using some of your handset information that you've pulled into that, maybe some of your active testing or some of your device testing. So you've got that kind of high-level location view. That gives you kind of red and green circles, which can be, red bad, green good. The bigger the circle, the more subscribers affected. So then if you drop down, you might want to look at that from a service perspective. Maybe you want to look at video throughput, or you want to look at VoLTE voice quality. And here you can kind of build a model around that, where again, you can have certain kind of KPIs around that, and you want to focus on the red being bad, and the bigger the rectangle, the more subscribers. So that helps you make kind of good business decisions, because you're looking at service affecting issues and the number of subscribers affected. So then you kind of move down into what I would call the kind of ARAM view. So this is around accessibility, retainability, integrity, and mobility. So you might build some KPIs around those particular metrics, and be able to kind of have thresholds set against those. The important thing is that one KPI for one operator may not be the right one from another operator. So being able to have that kind of flexibility to build that model is really important. Then I go down to what I would call the network performance view. Now, typically in the past, you would have gone to a kind of call trace window here. But here we're now looking at, it's the KPIs that are going on between the elements as part of that kind of end-to-end chain view that we talked about, all the way from kind of handset into the core. And again, building your kind of KPIs around that and generating, the high-level business impact faults so that you can make some good decisions. Then again, you can click down into root cause analysis. So maybe you want to look at, what's the what's the video throughput? What are the VoLTE dropped calls? What about my handoffs? What about dropped service? Those sort of things where you might be kind of graphing over a period of time. Now, the good thing is that you could have resolved potentially up to 80–90% of the issues before you've even had to build a transaction tracing view. And you would only do that and auto-launch that kind of transaction tracing view on demand. Again, before, when traffic levels were significantly lower, you would have typically kind of built those, for every transaction. And now you only need to build those on demand, and actually very rarely have to analyze them, because you've got such a good kind of KPI view at the top level. You've often resolved these transactions between these devices that are affecting that service, and you can very quickly get to a kind of root cause analysis based on that. So that kind of SMARTmetric, automatic drill down, filtering of data really helps the customer focus on the KPIs that are having the greatest business impact, and thereby maximizing the customer QOE. So on that, back to you, Stefan. Thank you.
Thank you, Paul, for and Scott, for this fantastic illustration of what is possible to achieve today in mobile networks. Let's jump into the conclusions. So basically, what we learn here is that quality over quantity matters the most. And I'm saying that because, as you've heard, there are many KPIs all over the place, and we keep adding new KPIs. Now with LTE Advanced, and soon 5G, that I mentioned for the first time. We don't even know what it is, but it's going to come for sure. So that will add on top of the challenges. But the big thing is, how do you make the best out of that tsunami of data you are collecting from the network? And the key thing is, you have to identify the parameters that will directly affect the quality of experience. And you may have different tiers of customers. I mean, from platinum, those who pay the most, you want to pay attention to them, while those who pay the least have a lower priority. The end game is, you need to find the tool that will help you deliver the optimal user experience. And some kind of analogy is, think of LTE Advanced as quantitative easing. It means you have a lot of you get bombarded by more and more data, but if you have the right tool, as presented by Paul and Scott, you have the ability to go get a few right KPIs that will ensure quality. And basically, yes, I started by saying that we have to deal with those multi-vendor, multi-RAT radio access technology networks with soon 5G on the corner, and we'll keep having thousands of KPIs. However, the question is, can we actually afford to have those thousands of KPIs? That is a big question, and the answer is we can keep them, but we need to sort them out to make sure the end user has a good experience. And all of that leads to 24/7 monitoring, end-to-end real-time network visibility on packets and sessions, and the end-to-end view of the whole network with geo visualization. And of course, the good news, as we saw, there are very sophisticated commercial products that address all the above. So that is looking fantastic for the future. With that said, I would like to pass over to Joanne for the Q&A session.
Thanks, Stefan. And I know we're going to get right to the Q&A. So we have a lot of questions coming in, which is great. Thank you, everyone in the audience. And I know Paul, Scott, and Stefan want to get right to the questions. And please, yes, as a reminder, just continue to ask your questions during the Q&A session. We have a lot here. Anything we won't get to, I'll just remind you, we'll reach out directly to you with your answers. So please continue to ask questions during this session. And Stefan, do you want to get started with the first one? You can get started there?
Yes, sure, Joanne. Yeah,
excellent.
So the first one is, what are the main right KPIs for optimizing LTE and LTE Advanced networks and to evaluate the quality of experience of the customer?
Yeah, it's Scott here from Accedian. I can take a stab at this. I mean, these are fairly broad questions, but the actual what we should focus on here might be the difference between LTE and LTE-Advanced. And in our experiments with this and all the different deployments we've also done with operators, notably in South Korea and Japan, where these networks are being widely deployed, it really is the timing, the synchronization, and the latency of these measurements, especially in a one-way fashion, that are quite critical to ensuring seamless handoffs and also the ability for VoLTE calls to be made and conducted. So there are, as Paul mentioned, fairly straightforward and easy ways to show the MOS score of a VoLTE call, but that's not usually the problem that we see when we're looking at deployments in places like Korea. The problems tend to be more about the handoffs between networks or between towers or roaming between LTE and LTE-Advanced networks, and in that case, it's really the synchronization and delay that make the biggest difference from what we've seen. Paul, I'm sure you have a perspective on this one from at least the RF side as well, right?
Yeah, sure. Yeah, good. Thanks, Scott. I guess the first thing I would say is that one operator's KPIs may be different from another operator's. So there's no, here's the 5, 10 KPIs that are good for everyone. The other thing, I guess, is KPIs focused at that kind of service level are important to kind of start off with. So maybe it's VoLTE, maybe it's video, maybe it's background interactive traffic, maybe it's torrent, maybe it's gaming, and those will have different KPIs to represent them. The other part of the equation, and we've touched on this through the presentation, is that real-time aspect of it. Getting measurements that are real time, particularly when you've got a kind of service like VoLTE, where you could have a 10-minute call. The first 5 minutes is good, the second 5 minutes is terrible, but on average it seems okay. Well, that's no good because the customer experience has been poor. So getting that kind of real time nature is important. And I think the again, this kind of end-to-end part. So I might want some device-specific metrics, like I mentioned, like for example, received power. At the same time as knowing what my voice quality or handoff capability is. So it's knowing kind of where you are in your deployment, what service you're wanting to measure, and again understanding that from a kind of end-to-end perspective.
Thank you. I think we can move to the next question. Is the virtualization expected soon for the RAN part? What is the impact gain on the operational task? Is there any gain in the OpEx, and how? So this is, about the future. So either Paul or Scott, if you have your take on this.
Yeah, sure. Thanks, Stefan. It's Paul. Yeah, good question, actually. I mean, virtualization will have a kind of major impact on KPI capture and generation. There's, of course, a lot of discussion going on at the core level in terms of kind of virtualizing the network and how you kind of orchestrate that. But at the same time, the RAN becomes a kind of important part of that. As you move to kind of cloud RAN, liquid RAN, whatever you want to call it, and the virtualization of that, the backhaul, front haul component changes. So there's a flexibility in KPI needed there, I think, as well as being able to align KPIs with that service. So maybe you need them from the device and from the eNode B, so you can kind of marry those together. It will certainly add complexity, because if you're on a physical interface capturing measurements, that can end up being a multitude of virtual interfaces. So being able to kind of orchestrate that data, but also there's the closed loop element here, because that data needs to then feed into the whole optimizing, self-organizing network as things become more complex. So knowing how those kind of KPIs can then feed into that, so that the right decisions are made at the network level to support the service and quality experience.
Well, yeah, there's a lot here going on in the RAN virtualization, and there's some whole new aspects here that apply as well. So if you're virtualizing these components, the question is, where are they being virtualized? And those locations also need to be monitored between the different virtualization areas. If you're chaining together a function that's in one location versus one that's more distributed towards the edge, if you're using a distributed NFV strategy versus a centralized one, a combination of both, what's the performance between these virtual network functions themselves, so to make sure that they actually live up to their physical counterparts. I guess that's one part. And the other thing is that instrumentation itself that's going to provide the KPIs and the visibility on these CRAN systems has to also become virtualized to some degree, so that they can co-locate VNFs that are related to the performance assurance itself with the actual CRAN components that are doing the heavy lifting for the actual transaction. So these are a couple things to consider, is how and where will these things be virtualized, and how and where will you be able to do the similar approach on the instrumentation side, so you don't lose the visibility as these things move more towards the virtual network function implementation.
Yeah, and in fact, there is a lot going on, in terms of work on RAN virtualization. But to really answer the question, is it coming anytime soon? I would say no, because you're not going to rip off your existing network to implement virtualization. That's number one. And number two, there are still many technical issues to be resolved. FDD, actually, LTE, looks more ripe than TDD. In TDD, you have to look at synchronization issues between the A and B. So there is work going on, but don't expect it to come anytime soon. Next question. This is a very interesting one, actually. It's about the KPIs from device. Because, what can you, Scott and Paul, elaborate a little bit about the KPI coming from the device? Because with the same KPI, you may have actually a very different measure depending on what device you are collecting the data from.
That's so true, Stéphane. The biggest problem is that different devices have different levels of dedication towards their precision and accuracy, for example, in measuring a KPI. So if you take a measurement from let's say a network element, the CPU may be doing some of the time stamping and required analysis to make these measurements happen. A dedicated piece of instrumentation clearly will have an advantage in scalability and accuracy. And then you have fully virtualized agents that running on virtual machines with free running clocks that can't accurately timestamp anything in a regular manner. So I think what's important here is that the KPIs may be similar, depending on whether they're time-oriented or not. What's important to the operator is to know the accuracy of each of these KPIs so as to use them within the capabilities that they offer. So if you have a latency measurement, for example, that's 10 milliseconds and it's inaccurate by plus or minus 5 milliseconds, it's probably very good to know that, so you don't compare that directly to one that has a microsecond level of precision. So actionable metrics also should be quantified along with their current precision that's available from the device that's providing it based on its own state to be able to report the metrics. And that's similar to, say, synchronization clock sources. So a grandmaster clock or multiple grandmaster clocks will report their accuracy to the other clocks, so the distributed clocks or boundary clocks, for example, can actually choose which grandmaster they want to go to. So this is the kind of thing that also needs to be rolled up into these metrics.
Yeah, and thanks, Scott. That was good. I would just add, getting metrics and KPIs directly from the UE is fundamental in understanding the kind of end-to-end service. It gives you an exact representation of what the user's experiencing. I touched on this earlier on because you can map the service metrics that you're doing. You can actually exercise the network from that device. At the same time as gathering some of those more detailed RAN metrics that you're receiving, from the handset between that and the base station. So those become fundamental, and if you can capture those and throw them into the cloud and merge those into your OSS, you've got a very rich pool of data in order to generate the KPIs you need.
Thank you, Paul. So I think we have reached the end, and I need to pass it back to Joanne. Joanne?
Thanks, Stefan, and I know we have a lot of questions, so, thank you, first of all, to the audience. Thanks, everyone, for participating. We appreciate your being on. Also, I want to, many thanks, especially to Stefan and also Scott from Accedian Networks and Paul from JDSU. A really good presentation here. I think a lot of good information, and obviously from the questions we're getting in from the audience, a lot of great detail and a lot of interest in this topic. Just as a reminder, we will reach out directly to you with answers to your questions. So thanks everyone for participating. You're going to see a survey about Infonetics webinars. We'd love to get your feedback here. We always want to improve our webinars, so please answer or fill out the survey. Let us know what topics you'd like to hear about in the future. Again, thank you for joining us today. And you can review this webinar at the link that you're seeing here. You can review this over the next 90 days, so feel free to come in and join this webinar again or share it with your colleagues. And please join us for future Infonetics events. Again, thanks to everyone here on the session. Thanks to Accedian and JDSU, and have a great rest of your day. Bye-bye.